So here are these 4 zones, okay? Now, here is another very important concept. You know, we're just talking earlier how that over a 6-month period, the sun's moving higher in the sky till June 21st in the northern hemisphere, and then appears to move further down in the sky as the sun travels to the south. What it does is it drags these 4 zones with it. So these 4 zones do not stay static in one place throughout the year. Remember, the intertropical convergence zone is wherever the sun is directly overhead. So, right now, today is the spring equinox. Today, at solar noon, the sun is directly overhead 0 degrees. That's one of the defining things about the equinox. Solar noon, 90 degrees, directly over the equator at 0 degrees. All right? But, over the next 3 months, the sun will be directly overhead of 23.5 degrees north, which is the Tropic of Cancer. So the point is, this zone is going to move north. The sun's going to drag it to the north over the next 3 months. It wants to stay under the sun. As a result, all of these zones are going to move north. They're all going to move north over the next 3 months. And then after June 21st, they will slowly start moving down to the south. Now think about this for Prescott. What does this mean for us? Well, how would you just generally describe our climate? Somebody just landed here from Mars, and they walked up to you, and you got to describe to them, how would you describe Prescott's climate to somebody from Mars? Or New York City? Not you're from New York City. Seriously.
Hot and dry.
Thank you. That's kind of how I would describe it, right? So warm and dry. And why are we warm and dry? All right, Ruben said hot and dry, right? I heard him say that, right? Okay. If you look here where Prescott is, and it was generally Arizona, we already figured out what our latitude is. We run about 35 degrees here. Phoenix a little less than that, right? We're smack in the middle of subtropical high pressure. Boom, we're done. That explains our climate, right? Pretty much. But also think about this. We get 2 times during the year when we can expect to get precipitation. We call it, we've got this double maximum precipitation. Winter and during the summer monsoon. We've had about 7 low pressure systems travel through our area this winter, from say starting in November to now, late March. That's because that subpolar low pressure area travels to the south in the winter. The sun is pulling all of these zones down during our winter and then back north during our summer. All right? So the reason we get winter precipitation is because the subpolar low pressure zone comes down closer to our area, and some of these storms come far enough south to hit us. What's going to happen now? If you look up there at the zones, what's going to happen now over the next several months to the zones? What are they going to do?
Shift north.
They're shifting north. What's that going to do for our weather? If we're going to see the subpolar low zone and the subtropical zone both move to the north, what zone's going to dominate us over in the near future?
Subtropical.
Subtropical high. This is why we get no precipitation essentially in the months of April, May, and June. April, May, and June are incredibly dry months here because that subtropical high pressure zone comes up and we're smack in the middle of it. So it's deflecting all the storms away from us, this high pressure. So that explains why, first of all, why it's mostly hot and dry here in this part of Arizona. But that also explains why we get this winter precipitation. We allow the subpolar low pressure zone to move down, well, the sun allows it to move down into our zone, and we get occasional precipitation. Now this winter has been abysmal for precipitation in Arizona. We are probably running 30 to 50% of normal for our winter precipitation. So we can't, it's a spotty thing. It's not going to be like a monsoon that India gets, moves into our area and we're going to rain and snow all winter. It's not like that at all. It's these migrating low pressure systems that may or may not get us. And we didn't get very many this winter. Now winter's not completely over, although today being the equinox, we don't have much winter left, I'll tell you that. Okay, so what I'd suggest to you here that as these zones move back and forth, you can really now explain and predict the kind of climates you're going to see in a lot of different locations, okay? So this is a very important concept, this concept of the global circulation model. Now, I want to show you the real world. This is kind of like the real world here, but let's actually start with, we'll start with January. What you're looking at right here is a map of, this is how it really is now. We're not doing any kind of idealized thing with planet Earth, all right? What we're looking at is these systems I just talked about: subpolar low, subtropical high, intertropical convergence zone, polar high, and their average positions during the month of January 1st. Then we're going to look at July. Okay, we've just come out of winter, so why don't we start with the winter time here. Now the polar high is definitely up in this area here. Remember what the polar high here, clear, cold weather. In the winter time, remember what happens, all these zones are going to shift to the south. So what happens occasionally, and it's happened a lot this winter in the United States, this polar high will briefly move down and across the United States. That's what's being depicted here, Canadian high pressure. It starts in Canada and then it moves down into the United States. We've seen temperatures of 64 degrees below zero this winter in Minnesota. So it's been an extremely cold winter in these places. So that's this Canadian high part here. The subpolar lows are represented, one anchored pretty much in the North Pacific, one anchored over here in the North Atlantic. Okay, we have names for these, and you should know the names for these things because these are very important. So this fixture we get out here in the wintertime, this big subpolar low pressure system, is called the Aleutian Low. Let's go to the world map here. The Aleutian Low is named after the Aleutian Islands here, okay? Because that's kind of where it hangs out. Now here, I'll ask you something. You guys ever watch, I think it's a Discovery Channel program called The World's Deadliest Catch? Have you watched that? That's a really interesting show. These guys are fishing out here. They're fishing right in the middle of this Aleutian subpolar low. They're nuts! I mean, seriously, you guys know what I mean? I mean, you can understand now why it's so rough out there. They tend to go out there right where this subpolar low hangs out. Now, it's not like these systems all stay stationary like they're showing here. These are like general average locations of them. This Aleutian low, well, these are the lows we're going to get occasionally. This low can move down in the winter and sometimes cross the southwestern part of the United States, and we can get a storm, we can get snow, we can get rain. Okay, so the Aleutian low affects us. Rarely does the Canadian high affect us because we have this nice barrier called the Rocky Mountains off to our east that tends to hold that back. Now the other issue is we tend to have mostly westerly winds going across the United States, and that tends to blow that cold air off to the east. And they've had a lot of it this wintertime. All right. If we look off over here, there's this low, this semi-permanent subpolar low pressure system. We call it the Icelandic low. Okay. So the Icelandic low over here. Okay. Now a couple of other high pressure systems that are very important for our climate. The subtropical high pressure, the specific one that affects us, Pacific high, okay? When Ruben talks about it being hot and dry, it's because of the Pacific high pressure, specifically that subtropical high pressure system, all right? And we have off the east coast one called the Bermuda High. Let's go to the map and show you something here. Okay, let's start with the west coast. Now, if my hand would be depicting the Pacific high pressure system, the general circulation around high pressure, you guys, clockwise, okay? Clockwise around my hand. Now, the wind is also pushed outward, but it's clockwise. Now, another thing to consider, most ocean currents are driven by surface wind. You know, ever wonder, why does that ocean current go that way? Because the wind tends to blow that way. So the winds push the water and create the currents. Now, if we got a clockwise circulation going around that high pressure, what direction would the ocean current be off the west coast of the United States?
South?
Traveling to the south from the north, okay? That's what's happening. And you know how you can tell that? Has anybody ever gone swimming in the ocean anywhere from San Diego to LA? How would you describe the water temperature? Generally, you don't have to give me a number.
Cold.
Very, very cold.
Carmel is really cold.
The further north you go, the worse it gets. By the time you get up off that area, Carmel, San Francisco, it's got some of the coldest ocean temperatures around the United States. It runs about 52 degrees Fahrenheit up here, even on a hot summer day. Because it's driving this water down from Alaska, and it's very cold, all right, because of the clockwise circulation of the Pacific High. I mean, you go down to San Diego in the summer, you're thinking that's warm water, think again. You know, a warm water day off San Diego is 68 degrees. Now, I don't know if that means much to you, but 68 degree water feels very cold. All right, so Pacific High, clockwise circulation, driving cold water down the west coast of the United States. That water's always cold. It's never going to get warm. Now, if you want warm water, go over here. Okay, there's my hand, high pressure, clockwise circulation. Look at the difference here. What's going on here, this high pressure is driving this incredibly warm water up the east coast of the United States. Now, have you ever been swimming off of Florida or North Carolina?
It's warmer.
It's really warm. I've been off both coasts swimming in this water, and I can tell you, I've been in the water out here sometimes when the water temperature is 86 degrees. You can frequently get water in the low 80s out there, and that's really nice, okay? So much warmer water just because it's on the return side of the high pressure system out here, okay? So that's an important thing to consider and to keep in mind.